Hello friends, welcome. This is third lecture in the course A Hands-on Robotics, and today we will simulate inverse kinematics of two-link manipulator by using MATLAB environment. So as you can see, this is online version of MATLAB. So you can easily use this version just by login using your college email id if you are a student. Okay, so I used my college email id to log in this MATLAB environment, and this is the window. Here you can write your code, and this is figure plot. Okay, so step by step we will code what we derived earlier in lecture number 2. So you can see here in lecture number 2 that we derived inverse kinematics for theta 2 and theta 1. Okay, so you can find out, you can calculate very easily theta 2 for given position of end effector in workspace, and that position is represented by xe and ye, and all other variables like this is L1 L2 and this is constant because this is link length. So just look this code. Here in this code you can see this is first line, this is close and clear all this, and this is n is equal to 100, n is a variable, and 100 is the number of point, how many points I have taken. So I took total 100 points in the this x and y space. So that's why n is 100. So x is equal to line space 0, comma 20, comma n. In the sense, x is a variable and it's spanning from 0 to 20, and there is total n points, in the sense 100 points. So you can see from this location 0 to 20. So from 0 to 20 there is total 100 points. Okay, now y is equal to, this is sinusoidal decaying function, you can see here 10 amplitude, maximum amplitude of this function is 10, and this is exponential to power minus 0.2x into sine x. And as you can see here, I am shifting all the points x and y. Why? Because you can see the end effector coordinate in the this xy plane. You can see this is the 0 0 point. This is the origin of this complete system. Okay, and we have to shift this x and y, because otherwise it will start drawing from, it will consider 0 at this location, and your end effector cannot move up to this location. So that's why I shifted point x and y in xy coordinate each 10 steps. So you can see here x is equal to 10 plus x. I shifted this x 10 unit in the rightward direction, and y is equal to y minus 10, in the sense I shifted this y 10 unit in downward direction. You can see easily, see this is the new coordinate system. See, this is 0 0 for this equation. Okay, so this is now, this is after shifting, this is 0 0. So it will start drawing from this location like this. Okay, so as you can see, size of x gives you number of element in the array x. Okay, so L1 is equal to 18.5. Actually this is hands-on course in robotics, so I used a robot to link manipulator and I code that robot in Arduino IDE. So I will share the design file also in the next class. So length of link 1 is 18.5 centimeter, and length of link 2 is also 18.5 centimeter. These are two variable, these are constant, because length of each links is constant. Now this is for loop. So this xy is desired trajectory. Okay, this is desired trajectory. I am generating desired trajectory by using this function. You can change this function as like you can write y is equal to 5 cos x also, whatever you want. You can give point any points in this any trajectory in this two-dimensional space, certainly it will draw. So up to this point, up to these lines, we created a trajectory and we are asking robot to track that particular trajectory. So we will look in this for loop. So as I told you, theta 2 can be calculated for given trajectory as equation, this equation, x square plus y square minus in bracket L1 square plus L2 square divided by 2 L1 L2. Okay, so theta 2 will be cos inverse. So just see here, you can see theta 2 is equal to x square plus y square minus L1 square minus L2 square. Here theta 2 is equal to theta 2 divided by 2 L1 L2. Finally theta 2 is minus a cos theta 2. What I told you that it can be minus, negative or positive. So that's why I am taking minus sign here. You can take positive sign also. So this is just for orientation. This is suitable orientation for me. Otherwise, it will go in this way. So that's why I took minus sign. So theta 2 is clear. Now, see, I am storing this theta 2. See, I calculated theta 2 up to this location. This is complete theta expression for theta 2. And I am storing this value of theta 2 in a array. You can see this is capital. Okay, this is small, this is capital. So I am storing this theta 2 in this variable theta 2, and so I will store all the calculated point of theta 2 in this in this array. Okay, likewise I also calculated theta 1. You can see in this formula we derived a formula that theta 1 will be tan inverse y upon ye upon xe minus alpha, where alpha is L2 sin theta 2 L1 plus L2 cos theta. So you can see here, see, I'm using same formula to calculate this theta 1. See, a tan in the sense tan inverse yi divided by xi minus this is complete value of alpha. So I have already told you that alpha is equal to a tan L2 sin theta 2 divided by L1 plus L2 cos theta 2, and we already calculated theta value of theta 2, so we can easily put the value of theta 2. Finally, I stored complete all the values of theta 1 in a different array. Okay, so you can see here, this is theta 2. I stored value of all theta 2 and theta 1 corresponding to given coordinate x and y. Okay. Now we have inverse kinematics relations for given x and y, and we stored those particular theta 1 and theta 2 in a different array, theta 1 and theta 2. Now look here, just to plot. Now inverse kinematics is complete up to that location, up to this location. Now we are just to plot this complete robot on this in MATLAB environment. So what I did, I generate the point x1 and y1. So x1 will be, if theta 1 is given, if theta 1 is given, this angle is given, so certainly x1 will be L1, this one actually. So L1 cos theta 1 and y1 will be, we are talking about this point. Okay, then we can plot a line from this location to this location. So that's why x1 is equal to L1 cos theta 1 and y1 is equal to L1 sin theta 1. So likewise I also calculated x2 is equal to x1 plus L2 cos theta 1 theta 2 and y2 is equal to y1 plus L2. We also derived this expression here. Okay, see this one. Okay, you can use this one actually just to plot. Just to plot this line, link 1 and link 2, we are deriving these po- we are generating these points x1 y1 and x2 y2. So now we have all the points. We have coordinate that at 0 0, and this end of link 1 is at x1 y1, and base of this link 2 is at x1 y1, and end effector is at x2 y2. So now we can easily plot. See, this is clear all. Okay, so clear all in the sense this will clear all the figure, existing figure in each step. So now I am plotting this point base of this robot at 0 0. So that's why plot 0 0. Okay, so this is marker size 5. So you can change this value, then this will size of this marker will decrease or increase. Okay, marker color is blue. Now after base I am plotting this line in the sense link 1, and link 1 is given as line 0, because this point is can be given as 0, x coordinate is 0 x1, and y coordinate is of this link, actually line L1 can be written as this end is 0 0. So first value of these points will be 0 x1 and 0 y1, in the sense 0 0 and x1 y1, and line width is 5. Likewise for this link L2 also, this represent a line from this point, in the sense point x1 y1 to x2 y2. So that's why this is x1I comma x2I and y1 comma y2I, and I am keeping line little bit less, so this is line width is 2. So finally plot x to y2, this end effector. So I am plotting finally position of end effector, and this is given as x to y2, because this is the complete xey. So in this program x to y2 you can relate with xey in this formula. Okay, because that is position of end effector. So finally axis is given, axis in the sense you can limit axis in MATLAB. So all the axis x and y is equal. Grid on, you can, this is grid, so you can turn it on or off. So pause 0.1 second, so it will pause. So first it will draw go at first point, then it will pause for 0.1 second, then again it will go step by step in all the points. Okay, let me run the program. See how it's moving from this point to, it's tracking the given trajectory. So as you can change now, if you are planning to give another trajectory, so you can give here. So just change the plot, c y. So just by using percentage sign you can give, you can comment in MATLAB. So now I'm giving y coordinate as 5 cos x. Let me run. So x is already given. Okay, now y is equal to 5 cos x. Let me draw. So you can track a given trajectory, any kind of trajectory in workspace. You can plot just by using this tooling manipulator. Thank you. Thank you for attending this class. We will meet in next class.